Let me talk about myself. I'm Abhishek Mishra. I'm a developer advocate at YugabyteDB, which is open source distributed database. I'm also a very big Python fanboy. I've been doing Python programming for quite a long time, and before YugabyteDB, I've been doing backend engineering for almost 5 years. And I'm a community first person. You could find me in a lot of community events happening around Chennai, India. And I do organize a few meetups across India as well. And I'm not a 10x engineer. If you don't know what 10x engineer is, definitely you should go and read about it. And if you want to connect with me over LinkedIn, these are my handles. Let's go. So I'd like to start with, can anyone answer this? Does the cloud run 24/7? Yes? How many are saying yes? Very few hands. And so rest of are like with me? No? I'm saying no. Okay, how many of you have used cloud, public cloud infrastructure? Okay. So I want to ask this question again. How many are saying no? Okay. So mixed crowd. Got it. So I am in a favor of no, and I'll tell you why. So, I mean, these are the things. If you go and check every day or probably once in a week, there will be some outages happening around the world. And if you have heard of the recent outage, in fact, Zoom and whatever public provider you use, right? They say that we give you 99.9 percentile, but when the outage happens, it happens. You can't really do anything. So, one of the reasons why outages happen, anyone? I won't judge your answer. You can just feel free to like talk anything. For? Okay, that is one reason. Okay, that is also there. Yes. So I think everyone is pretty expert here. They know how and why cloud outages happen. So one of the major reason is, of course, natural calamities, right? Because that is something that you cannot control. So even if you are building your own data center, you will make sure that things are proper in place. If you will make sure that every practices are best practices being used when building your infrastructure or whatever, right? But you can't control the natural calamities. If storm happens, it happens. If earthquake happens, you can't control that. So that is one of the reasons, right? Like you cannot. So when someone says, now I think you have like some thought about it. So when someone says, does cloud run 24/7? The answer is no. Yeah, that's right. And the only things that you all can control is things that you're building on your end. So probably the application that we're building using best practices, design pattern, all those things. So this is what we do when we are like, oh wow, our application is deployed on cloud. Now let's, we are free, no worry at all. And then, but then when cloud outage happens, this is what we do. And it's very, very, very obvious reason. I don't know how many of you have been in production systems and have seen services going down and you'll be like, oh, they said it's going to be up for 24/7. So yeah, so today's, this is how it happens. So everything fails. Does anyone know who is Werner Vogels? So he is CTO of Amazon. So in fact, one of the pioneers who started AWS. And in one of the outages back in 2019, US West region was down for almost 3 to 4 hours. And then people asked why it was down. His answer was, everything fails all the time. So, I mean, we should accept the fact that AWS is very massive, and then if something coming from a CTO of AWS, of course they are being mindful about it. But then the only things that everything fails eventually, whatever system you build, it's not resilient from start. So you have to make sure how you build it, and that's how this talk is going to be all about. So you have to make sure how you can reduce the impact of particular outage or how resilient your system can be rather than building it as a foolproof solution. There is no foolproof solution at all in the world that exists. So that is the reason they say 19.9 and that 0.1 is still random. So in today's talk, I'm going to cover this agenda. We already gave a thought about what cloud outages are. We gave thought about it. And I'm going to talk a bit on global infrastructure just to set the audience expectations as well. If anyone is new here, we're going to quickly cover through what exactly different availability zones and regions are. And then we'll talk about what are geo-distributed apps and what are the components on it. And apart from that, we'll also see that how you can build resilient data layer for your application. So to set an expectation for this talk is not going to teach you anything new. These are the patterns that you might already know, but it's just that you haven't used it. Or probably you jump to the conclusion because you want to scale the app. And in this talk, I'm not going to talk about how do you scale your application. I'm going to talk about few patterns that you can use to build resilient database layers. Because whenever you talk, okay, I have 100 users now. Now let's say my users are going to increase in future. I'll just create multiple instances of application. I'll use Kubernetes or whatever solution that exists, which is very hyped. And then I'll just scale it. And my Kubernetes will handle it. But what about database layer? Because this is from my experience, my observation. Most of the time when we talk about scaling application, we talk only from the application perspective, whether it's front end, back end, or services. And most of the time we forget about database. Because we're like, okay, database is there, unless and until you don't hit a lot of requests, and if your database goes down or if you face latency, you won't be bothered about like talking about database at all. So the entire agenda is around that. So what exactly global infrastructure is? Cloud providers? So basically when we say global cloud infrastructure, usually we don't intend to talk about on-prem systems because that is very, very, very much prone to breakdown because not everyone is expert into building infrastructure. So when I say about a global infrastructure, I'm going to talk mostly about the different cloud providers, not talking any specific to any cloud provider. So typically all cloud providers have regions, right? Which is nothing but independent geographical locations where they have data centers, right? So if you talk about Azure, you will have a US East 1, North Europe, etc., etc. And this is like just a very basic example of it. And then again, these regions are also interconnected, right? When you say I want to deploy something on US data center or something in Europe, how do you do that? Because they already have a data center there, and then these data centers are interconnected through large networks. They have a region networks, but of course there are latencies between networks as well, between different regions. So if you want to, this is just an example of one of the reasons. So if you want to send a request from Oregon to North Virginia, the average latency is 60 milliseconds, and likewise for others, right? And usually all the regions will have availability zones, which we'll talk. I'm just giving you this just to set a, because in consecutive slides, I'm going to talk about how exactly you're gonna deploy things. And usually all the regions have zones, which is called as availability zones, to make sure that within a single region or in the nearby availability zones, even if any cloud outage happens, you have like multiple availability zones so that it falls back to another zone, right? And this is one of the examples of it. And again, zones are connected through network wires and all those things, but the latency usually between zones are less as compared to regions, which is very obvious, because the location distance is very less, and that is the reason. But in Azure, I was surprised to see, in fact, is that round-trip network latency between any availability zone is less than 2 milliseconds, but in other cloud providers, it's a bit high. And I was really surprised to see that. Yeah, and usually zones are, in most of the cloud providers, 3+. Or it could be more, but minimum I have seen 3. Probably the reason is that they might be using the algorithm behind the scene which requires at least 3 nodes to fall back. And there's something called local edge zones as well, right? Which is again it could be within availability zones, or it could be within the densely populated city areas. It's not very popular, but still a lot of cloud providers give you this option for edge computing, IoT devices, and all those things. And these are basically used to where you have a very low latency application to build. So streaming application, gaming, and all those things probably, yeah. So all cloud providers have this. I'm taking name of these three because these are like, of course, very major cloud providers. And if you want to know more about entire Azure global infrastructure, this is like a very interactive map sort of thing. You can go check on which region, what are the different availability zones are there, what are the latencies and all. So it's pretty well. So you can like take a screenshot of this if you want. And again, this slide is available publicly. I'll share at the end. So what are the things that we can achieve with global infrastructure? The first is, of course, you can increase the performance. So let's say, for example, if you're building a corporate Slack messenger sort of application, right, where you have multiple users from different locations, right? So you have to make sure that the performance, when I say performance, the same experience of using the Slack messenger app across the globe should be equal. And how do you achieve that? Global infrastructure helps us in putting that because they have a different availability zones and all those things where you can put instances and you connect through it. And then second is to comply with data data compliance things. We all know what is GDPR, and we also know that currently, I mean, recently RBI had released right policy that the financial data should not be stored outside India, and it should be within, right? And you should not save on your end. So those kind of compliance data. And then third is, of course, how you can technically withstand the cloud outages. And today we are going to talk about mostly on that part. So let's talk about geo-distributed application first because this talk is about that. Anyone knows what exactly this is? It's definition or the title is very obvious. What is going to be geo-distributed? Yeah? Yeah, correct. So like not very fancy term, but yeah. So when you say you have a geo-distributed apps, it's not just it's distributed across different locations or you have multiple global users. It also means that the app should be highly available, performance and compliance to data, again, all data compliance things, right? And these three things are very important irrespective of whatever app you will build, whether it's a developer tool or it's a corporate business messenger app or any enterprise app. You have to make sure that these three things are always there. Definitely, you will not always start building with this mindset that, okay, we have to compliance or something like that. I mean, during MVP and all, you won't usually think of that, but yeah, this is what it looks like. And you will also talk about, can I also call this as a geo-distributed apps? Yes, if it is not even globally distributed, but if it's within availability zone itself, you can call it as a geo-distributed apps as well. And same goes for if you have, within a different cloud regions, I would say. Let's say if you have one deployed on AWS, Azure, or let's say people do it hybrid and multi-cloud, yeah, that also makes sense. So now, yeah, this sounds like a very fancy thing, but why would you bother in building geo-distributed apps, right? So let's say we have a Slack kind of app, and we have 3 users from different regions. So Mr. Green is from Berlin, he's a scientist. This is not a tech company, by the way, so don't see it like, oh, who works, different kinds of job profiles. Let's say it's some company, right? Consultancy company, which gives you different services. So Mr. Green is scientist who's from Berlin, and Mr. Red from Mumbai, musician, and then Mr. Blue, financial advisor from New York. Now, if you say, let's say you release your first app, right? And it's in a single region with single application instance and single database layer, right? Remember why we need this, right? We started with why do we need a geo-distributed apps? And then some outage happens. And since it was a single instance of app and database, you can't do anything, right? And the reason why we need to build geo-distributed apps is geo-distributed app is, you can see like this is like a postmortem report of AWS outages all the time. And this is available for all the cloud providers. It's just not AWS, right? Even GCP, Azure will have postmortem reports. And you should definitely read that. The reason is that, okay, another thing I wanted to talk about is when you're building apps, we usually do not take care of latency between the regions. I have seen people re-architecting the application according to the latencies that is very less in between availability zones or regions. And then they have redeployed their database instances and applications. So you have to also make sure that. How do you know that? Because in those reports, they'll mention that because it's their job. They are providing you a cloud infrastructure and they have to comply with all those things, right? So they'll give you detailed analysis of what happened, what not. And these reports could help you in re-architecting your application if there are factors that you have not taken care of when starting, when started building the applications. So yeah, so this is one of the factors. So yeah, you have to accept the fact that the cloud outages can impact your applications. That doesn't mean that if you have deployed your application on cloud, it's going to be live 24/7. No, it's not going to be the case. Just forget about the enterprise legacy application when you say, okay, we are going to do migration and all that stuff. That is fine. I'm not just only talking about that. It could be monolithic application, microservice, anything in general, right? And second is that you have to design an application which is multi-availability zone or region-based, and which is nothing but geo-distributed apps. So what about, then people will also come, hey, we have a hybrid deployment and all stuff. Usually when you want to build high availability apps, HA, right? I'm going to explain this in a very naive term, but going to hybrid solution doesn't make sense all the time. You have to first make sure that your application itself follows the best practices, right? I mean, if you're not writing a code which is, let's say, which is supposed to scale and you haven't implemented multi-threads and all those things, keep on adding compute, it doesn't make sense. Even if you scale it just for a name's sake, it's not going to work out. So you have to make sure things that are under your control, how do you architect well, design patterns that you have used, basic computer science concepts like multi-threading and all, right? Then that is how you're going to solve without jumping onto hybrid cloud solutions. So you have to make sure at least you deploy AZ level applications, right? Then that's the process, that's how you do it. So, all right, then we learned that what to do. You deploy multiple application instances and databases, right? To make sure your regions you have a high available application. But second factor is also that, as I mentioned, the performance part of it. If you have deployed one cluster of application and let's say database itself within the US region, and if Mr. Blue is from US, right, it will be very fast for this particular person because it's within the same region and that person is trying to access. It's very fast. For people from Europe, it could be, again, distance is much, but of course the latency will be a bit high, but it's fine. The application is somewhat responsive. But then if someone wants to access from India, the latency is going to be much higher, right? And let's say even if you have a single instance of database, it's going to be much more on that. But what we want to achieve is something like this. For all the users, the experience would be same. So this is second reason why you need to build geo-distributed apps. And third reason is, of course, we talked about it, GDPR compliance and all those things. Can I check on time? Got it. Yeah, so if you have an application where Mr. Green from Europe is actually using your application, but if that person data is getting stored in different region, that is violation of the compliance. So these things are also there, right? So this is why you also need to build geo-distributed apps so that you can plan it accordingly. So again, geo-distributed apps were to summarize. We want to withstand the cloud outages. Second is to performance, and second is you need data regulation and all stuff. Now, these are the components. How do you build it? Is it surprising? Have you all already used this? So there is no science behind it. It's just that even if you are building a very simple application, these are the core components. The only difference is that you might use single load balancer, but in terms of geo-distributed app, you need global load balancer or whatever your cloud provider is providing for global load balancing thing. Application layer, you need multiple instances of that, not a single application layer, of course. So you create multiple instances using containers, Kubernetes, or whatnot. And the third is database layer. Data layer, when we usually go and build a database, application, we try to put it on a single instance, right? But that has to be distributed as well. And I'm going to talk mostly on how you can leverage distributed databases in building geo-distributed application instead of using a single instance databases. And why not use all those RAID replicas and all. Because scaling database is not easy. When you say you want to scale database, of course, there are two approaches, vertical scaling and the horizontal. In vertical, what you do, you increase the compute size or memory and all, but still it's a single instance, single point of failure, right? But when you want to do horizontal scaling, it's like you want to add multiple machines, but then how do you make sure that all machines are communicating with each other? Because you want to make sure you have a highly consistent data as well across the entire node. So geo-distributed databases, distributed databases make sure that even if you have used Cosmos DB and all, they have this feature where you can achieve it when you can build geo-distributed apps. So this is what a typical application looks like, right? User sends a request, and then load balancer takes care of routing the request. Whichever is the nearest application or instance is there, your request will go there, and that's how it works, right? But typically, this is how the application looks like when you scale it. Because if you remember, I told that we usually do not think from the database layer unless and until we face an issue. But what we want to do is, again, I mean, this thing we know that we already talked about it, like the latency and all. But what we want to achieve is something like this, right? But you can't do this with a single standalone database. Why? Because scaling is very hard. You could solve this, definitely. You could create multiple partitions of data called sharding and all stuff, but manually doing it is very cumbersome. And that's where distributed databases comes in place. Whatever you see right now, it could be easily done with distributed database. And for this, yeah. So we talked about problems. We talked why do we need distributed databases, and now we'll talk about what are the patterns you could use to deploy distributed database, mostly on database layer. So these are the majorly 3 patterns, and there is another one called Geo Partition Cluster, which is not very fancy, but I'll talk about that as well. So the thing is that, again, it is heavily driven by applications that we have used or I have experienced or building. These are very common things. This is not a silver bullet. And these points may not work for you as well, because different applications have a different use cases. But these are like a very most common patterns that you could use, at least as per the current infrastructure and then application requirements that we have. So yeah, let's see one by one how it is. And before that, I'm going to take an example of one of the distributed database called YugabyteDB, which is 100% open source, and distributed SQL database. So it's not a NoSQL database. So if you say we have a MongoDB and all stuff, scaling NoSQL database is a bit easy because you don't have to take care of the transactions, ACID properties, and triggers and all, because scaling those things are still very hard. So we are, so YugabyteDB is like fully Postgres compatible and actually built on top of Postgres. So the entire query layer, right, is being reused. And then we are inspired by Google Spanner architecture. If you don't know that, this Google Spanner is the first, one of the first databases that came up with the distributed architecture on SQL, and we are kind of inspired from them, and that's how we do it. And this is like a, if you see the blue, the blue box, this is a Postgres layer. But what Yugabyte has done is basically this 3 orange layers, right? Query optimizer, planner, and the executor. We have done bit of changes in those level so that. So it's very obvious that when you have a single instance of Postgres, you execute it, you don't know what goes behind. We just do CRUD operation most of the time. But when you say you want to do distributed query, the database is not capable of doing that. So basically, YugabyteDB has kind of did a manipulation on the query engine level, which makes sure that your queries goes distributed. If you have 5 nodes, it will execute according to that. And then again, distributed storage, we are using something called Raft algorithm, which makes sure that your data is consistent across during fault tolerance as well. If you know CAP theorem, okay, I mean, if you want to talk more about YugabyteDB, I am available after talk, I can talk more about it. So this is what a single multi-region cluster looks like. Very traditional, everyone uses it after POCs. So this exactly looks like you have a cluster. I'm talking about how you could do in any distributed database layer, not specific to only YugabyteDB, but YugabyteDB supports all these patterns. So the one of the way that you could do is distribute multi-region clusters in different regions. You, create a cluster and then you scale it. So what this pattern will help you in achieving is basically you can still withstand the availability zone outages. If any zone fails, you still have an option that the request will go through this other two nodes. Again, I'm saying that you on the application level will not take care of writing this logic of rerouting. So if one node fails, you will not write a logic to reroute the request to other two nodes. The distributed databases, the databases that are already present, they will take care of it. So my entire idea is, or point is that don't use standalone databases if you want to build a geo-distributed apps, use geo-distributed databases. It could be any one of the databases, not just YugabyteDB or not just Cosmos. Yeah, but the only problem is that, again, the latency will be high, as we discussed. If you have a multiple users across globe, that's going to be cumbersome. And second thing is you won't be able to abide by a data compliance. Now, second thing is that you can also do multi-region cluster with specific particular region. Like say you have a preferred region, and if you say that, okay, I start, my application is for Chennai users only first, right? So I'll definitely first go and create a cluster which is nearby Chennai, and then I'll give a preference over it. And the catch here is that now if you see this architecture, you will say that, hey, what if I send a request, and if one of the nodes go down, right? And how will the request will reroute? And second question is that how will I know which is the primary node, correct? Because usually when whatever we have studied in entire computer science, the most of the architectures are based on master or the primary and secondary nodes. So it will be like, even if you have looked through the Hadoop architecture and all, right, there is always a leader node and then there are followers. But then in this distributed app, each node acts as a primary node. So even if the request goes to any node, it's not like that you will get the the last write or something. In all the nodes, you will have the latest write. So yeah, each node works as a primary node. So you don't have to worry about which cluster, or sorry, which node you have to query first or connect through your application. Now second is you can do a single multi-region cluster with read replicas. And this is very helpful when it comes to increasing the read performance of your application. So let's say you don't have any, you don't want users, or if your user from different regions apart from US don't have privilege to do a write to an application, right? It's just a read requirement. Then you don't even have to deploy any cluster inside that region. You could just do with the primary cluster region, and then you could create a read replicas. And then whatever read replicas will do, whatever request comes through it, I mean from primary node, it will replicate it to secondary nodes, and that's how the application will work. But the thing here is that, again, we discussed in the last slide, you won't be abiding with the data compliance issues. And then if read replicas also fails, you don't have a provision to withstand that. And then the third one is you have dedicated cluster for each region, including, and this will make sure that you have your data compliance abiding. And of course, the performance with respect to each region will be fast. The only thing here is that what if you want this cluster data to be synced with other clusters, right? So that is the problem here, right? Because when you say from node replication within single region, it is very easy to do it. But when you do it globally with different clusters, how do you do that? Or let's say every month you want to generate a report from all the users from US, Europe, or India, right? So aggregating the query or doing the join across this cluster will be difficult, right? Because they are independent clusters. How do you do that? So in that case, there is something called Geo Partition Cluster, which this got nothing to do with your database. It got to do with your, how do you prepare your schema for your application. So you will say that each cluster will, or in fact table, you have to add additional column which will be with respect to regions, right? So if you want to, so basically database will take care of it in the sense if the request is coming from US region, right? Or from the US application side, then it will actually insert the data, look up into the table, which region it is, and then it will insert according to that. So in this case, if you want to do aggregate query and all those things, it will be easy for you to get it. I mean, so by the way, geo-distributed databases are mostly like SQL based or OLTP, not OLTAP. So you won't get all those aggregated queries or much, but definitely you will get whatever basic SQL features you have. So yeah, I mean this makes a lot of sense. You have a fault tolerance you can withstand your cloud outages as well, because even if the region fails, one region fails, other two clusters are still there, your request will be rerouted to it. But again, you have to make sure, like, how do you design your schema in this case? So I had a demo. Let me just, I'm not going to, like, I have already written a blog about it, and I just wanted to show you if you want to do a cloud outage, mostly on high availability, right? So I have this application, one second. So if you see this, it's a very simple app based on Django. What exactly this does is, there is something called PubNub, which is, I'll show you what this is. So PubNub is like a public subscriber based model. It kind of gives, consider this as a CDN, but for data streams. So they have some public data available. So let's say if you want to check for market data, each second you will see that some market data is coming in. So what this application does is, it just ingests this data and store into the database. But the only catch here is that it's not directly happening via application. We are doing it through something called message queue, right? And I'm using Celery, which is like a very popular Python framework for message brokerage and then task queue. So what happens is, like, any request comes to ingest the data, a task will be created and appended in the queue, and then Celery will take care. Celery will assign that task to a worker, and this worker will execute this task of ingesting the data from market and then putting into a database. This is what an application looks like, and so this is like a very, so if you see this screenshot, basically this is nothing but this is how it's a console app. I mean, not exactly console app, it's an API based app, but behind the scene I'm just kind of seeing how data is being ingested. So I have created one database cluster on YugabyteDB. I know it is not very clear on this screen, but I mean, if you go and read the blog, it has a clear view on it. So just to give an example, I've created YugabyteDB cluster, which has 3 nodes, if you can see here. And you can deploy it anywhere. So YugabyteDB anywhere is one of the flavors. Like if you have on-prem servers and all, you can kind of install it and choose where you want to deploy the database instances. So in this example, I have created 3 nodes on GCP. So once you do that, I mean, you could see that there are 3 nodes. Now the only thing that I have done is I wanted to see how exactly this works if any cloud outage happens. So I randomly, did a shutdown to any one of the nodes, which, okay, one second. This is fine. I think it got more to do with the GIF quality. It won't be clear. Yeah, one second. Yeah, I mean, I'm almost done. I mean, I have a app running, it's just that I haven't whitelisted the IP address. So that's why I'm not showing it right now. Yeah, anyway, so if you see like these 3 nodes, 1, 2, and 3, these are like created by Yugabyte. So when you deploy, you want to say, okay, I want to create a database cluster, and you say where you want to create, let's say GCP, Azure, or AWS. You can choose, and it creates VM instances basically behind the scene, and your databases are there. So in this application, I mean, in this particular example, what I've done, I have randomly chosen any node and have shut it down. So technically, when you don't have a distributed databases, what will happen even if you put down one node, it goes off, you will still face an error in your application side that application is unable to, it will raise an exception, unable to write to database or something like that. But in this case, what happens is, if you see, the one of the nodes is still unreachable. And I'm really sorry that GIF quality is not that good on the screen. So I do understand that it's not going to be like very clear. just to give an idea, but even if you shut down one of the application, the database cluster itself has a load balancing mechanism, or I would say there are two things. First is that it will reroute the request. It's not like you have an individual shards of PostgreSQL. It's like the nodes itself communicate with each other. So even if one goes down, the read and write request both will reroute to another two nodes. So your application will not go down. You won't face this write error or something like that, you know. So yeah, I mean, this is like a very naive example of how you can achieve high availability using distributed databases. There are much more than this, but yeah, so if you want to read more about what this application does and all those things, you can definitely check out this blog post, dev.do/coder or Yugabyte. And this is the application, the code of the application, everything is available. If you want to run locally, I have set up all the instructions and all. So you can go clone, run locally. So the basic question comes here, how do I start it? If you remember at the start itself, I've told you when it comes to hybrid mechanism, hybrid cloud option or deployment, don't directly go there. So if you have a compliance, then go with single database instance. If you want single DB instance, then you can go with Geo Partition Cluster. That's the last pattern I talked about. And then if you don't want to do that, you can have multiple standalone clusters. This is like a flow chart, like a very basic one. And then if you need faster reads, you can always create read replicas. Now the advantage here is that using any distributed database is that you don't have to create read replicas manually. You have to just mention the configuration, how many read replicas you want, which location you want, and then you can directly create it. So that's how easy it is using Geo-Distributed Apps. And if you want to learn more about databases and the scaling application, wonderful books, these 3 books by O'Reilly. Yeah, and if you want to learn more about geo-distributed applications or distributed databases in general, how does the sharding work, what happens behind the scene, and the architecture, and if you want to learn more about it, you can go to Yugabyte University. It's just like free. And yeah, you can connect with me again. And there is a very small announcement that I wanted to do. This is all with my talk. Okay, if you want to connect. Yeah. So thank you, everyone.